I'm here with Professor Beatriz NOHEDA from the University of Groningen. So welcome. Thanks for being here with us today.
Thank you very much.
So my first question is regarding the conference as such. So because it's bringing together like material scientists from all over the world, and could you share with us some of your personal highlights or what you're looking for in the conference?
Yeah, I'm looking for seeing what other people have to say and what is new this year. It's a very good place to see things that maybe you have not realized yet that people were doing. I think there are areas that I'm very interested in, for example, materials self-assembly, and we have a very nice awardee this year of the Mid-Career Award. We'll talk about that. Other things that are interesting from the program, for example, there is an invited talk by Emmanuel Dufay of the Luxembourg Institute of Technology on inkjet printing of piezoelectrics. I think this is a topic that will be very hot in the coming years because you can save a lot of material by inkjet printing the material. I'm also very interested in operando techniques, and here in Europe we have, of course, very good facilities like synchrotron, user facilities, and the fact that you can investigate materials properties in operando while they are working and functioning, I think is also one of the big topics of the future.
Okay, sounds very interesting. And why did you decide to come to EMRS?
Well, to tell about my research. That's very important in the right environment with the right audience, in a symposium where people are interested, but also to learn myself about what is going on in Europe. I think it's maybe smaller than other big conferences, but bigger than more regular conferences that are on one discipline, on one topic.
So you talked a little bit about your symposium, but what about the other symposia? Will you also visit some of the others? Because EMRS is also about interdisciplinary approach. Yeah. So
actually the highlights I mentioned were not on my symposium,
yes, okay.
Were in other different symposia. Certainly multidisciplinarity is a very important point. I think nowadays, if you look at how science is developing, certainly if your work doesn't have impact in other disciplines, basically it means it doesn't have an impact. So I think is multidisciplinarity and reach beyond your own topic and discipline is key at this point. Mm-hmm. So my own symposium is about polar oxides. And of course, I'm very interested in all talks on that symposium because it's very close to my research.
Okay. Speaking of your field of research, could you explain, like, in also what your research is about, and then maybe in simple terms and application-oriented, so people maybe who are not scientists can also imagine what your work is about?
Well, generally, I work on functional oxides, and I try to generate enhanced or additional new functionalities by working at the nanoscale. So by influencing the way the atoms and molecules are organized in the material, we change the symmetry of the crystals, and if you change the symmetry of the crystals, you generate new functionalities. So we look at materials that work very nicely in nature. For example, one of the areas that I'm very interested in ferroelectric materials and piezoelectric materials. These are materials that are used for actuators and memories. And then we look at how the well-known ferroelectric and piezoelectric materials work. We try to understand why they work so well, and then we try to mimic that with other materials that are more sustainable, more abundant, and easier maybe to make, creating new symmetries artificially at the nanoscale.
So if you say you look at what works well in nature, so you get inspired by nature?
Yes. Well, in a sense, maybe not so. You shouldn't think of biology or so, like but certainly, for example, I can tell you quartz is a very well-known piezoelectric material that you can find in nature. It's a mineral, and if you understand why quartz is a piezoelectric material, then you can create artificial materials that have better responses than quartz in your lab. That's what I mean.
So Talking about sustainability that you just mentioned, this is also something that we at Fraunhofer IWKS are working on. We do recycling and resource strategies. So can you tell a bit more how your work is looking into that and trying to be more sustainable within the materials?
Yeah, one clear example is on piezoelectric materials. So the best known piezoelectric so far, the one that is used in most applications, which generates actually €1 billion industry, is lead zirconate titanate, PZT. And more than 50% of the composition is lead, and as we know, lead is not desirable. And the EU has banned lead for many applications, but unfortunately for piezoelectric materials we cannot do that because there's no alternative. So looking for lead-free alternatives to piezoelectrics is a very hot topic and a very big topic of research in our field already for many years, but still is a challenge to find a good alternative for many different reasons. So that's one of the topics of research in my lab that has to do with sustainability. And we are trying to look for materials. So in the field of functional oxides, many of the materials that are used for memory applications, magnetic or ferroelectric memories, contain transition metals. And the idea is, can we generate similar functionalities like memory with materials that are more sustainable? And for example, could we have memories with simple oxides instead of with complex oxides that require less heavy metals? So this is certainly, even also in our topic, a very important area.
We are also looking into design for recycling, so thinking when designing new materials also into how to recycle them. And one of the ideas that are currently discussed is to make markers. It's like scarce resources or scarce materials or elements, so you can track them, and then once you recycle them, you know where they are. Do you think it's possible also? Is this approach that you think is viable?
I think it's certainly interesting to pursue this direction. Of course, at the moment the question is how to place sensors everywhere and how to maybe power those sensors. This is a more general problem, not only for the example that you mentioned, but also for the Internet of Things, for example. That is a promise that we have already for decades, but is actually not coming to be a reality precisely because first, we need trillions of sensors all over the world, and someone has to power these sensors. Batteries certainly is not an option. So that brings me to another very interesting topic, that is energy harvesting, how to harvest energy from the environment to actually power sensors that can, for example, help us, as you mentioned, to trace materials or trace all kinds of components.
Mm-hmm. So do you do research in this area as well, or is this just something that you see?
Yes, so within the research in my group on piezoelectric materials, we also look into energy harvesting. So this is about profiting from the energy vibrations in the environment. So in our environment there are vibrations all over the place, noise all over the place, and piezoelectric materials can harvest that vibration energy, mechanical energy, and transform it into very small amounts of electrical energy. And for powering a computer or a cell phone, we are not ready yet, and actually it's the question if piezoelectrics can ever do that. But for powering sensors, that is certainly an option. Mm-hmm. So there is quite a lot of promise.
Appliances.
Yes,
okay.
Yes. So microwatts of power you can certainly gather with piezoelectric materials. So that's a very interesting new area of research. Also.
Very fascinating. Yeah. Very fascinating. So thank you very much for being with us today. Thank you.
Thank you. Bye.